Hello everyone, I am going to explain question number 5 and question number 6 from exercise 7.4 from class 12. So we'll start from question number 5. Here we have to find out dy over dx when x and y are given in different parameters. So in part A, we can see that x and y is given in the form of theta. So we'll differentiate x and y separately with respect to theta. So we'll start with the A part. Here x is available as root sine 2 theta. So we'll differentiate it with respect to theta because x is in parameter theta. So here when to differentiate it, first writing the power notation. Now use the xn formula, that is n xn minus 1, and then the chain rule. So when you will use the chain rule, you have to differentiate first sine 2 theta, then again 2 theta. So here the formula which I used is x to the power n. It is n x n minus 1. Then chain rule applied to the sine 2 theta. So sine 2 theta differentiation is cos 2 theta. Then 2 theta's differentiation is 2 multiplied by 1. So this 2 and 2 will cancel, and because when you will subtract here, half minus 1 is minus half. Since we are getting minus half, minus sign is there, so it will shift down, and because of half, root symbol will come again. So the differentiation of x with respect to theta will come here, students. By mistake I wrote t, right here theta. So dx over d theta is cos 2 theta upon root sine 2 theta. Now why is this? Write it in the power notation. So x to the power n, differentiation is n x n minus 1. Then apply the chain rule to the cos 2 theta, then again to 2 theta. So when you will use n xn minus 1 formula, you will get half cos 2 theta, half minus 1. Apply the chain rule to cos 2 theta. So cos 2 theta differentiation is minus sine 2 theta, and differentiation of 2 theta is 2 into 1. Cancel this 2 and 2 and simplify it, because you will get here minus half. Subtraction of this is minus half. Because of minus sign it will come down, because of half root symbol will come here. So finally divide equation 2 by 1, that will give you dy over dx, and simplify, writing the power notation. So here power is 1 and here power is half. So both power is same, so power can come out. So you will obtain sine 2 theta and cos 2 theta is tan 2 theta. So that is your part A. Now we'll start the part B of question number 5th. Here the x and y is given in the parameter t. So we'll differentiate x and y separately with respect to t. So we'll start with x. X is a cos cube t. So we'll differentiate it with respect to t. So dx over dt is a will come in as a coefficient. We have to differentiate by x to the power n formula, that is n x n minus 1. So 3 minus 1 is 2. Then use the chain rule. Differentiate cos t, you will get sin t. So it's dx over dt is this. Now in the same way, y is a sin cube t. So differentiate it with respect to t. You will obtain x to the power n formula. You just use, that is n x n minus 1. Then use the chain rule. Sin t again just differentiate. So cos t. So that will give you dy over dt. Now divide equation 2 by equation 1. You will obtain this. Cancel whatever you can cancel. So you will remain with sin t upon cos t, that is tan t. So question number 5 is completed. Now we'll start the question number 6. It's very different from others. Here x cube plus y cube is t minus 1 upon t given to you, and x6 plus y6 is t square plus 1 upon t square is also, means these two are given to you, and with the help of these two given information we have to prove this result. So first we'll start by this given thing, and now since here you have x cube and y cube, and suddenly you are getting here x6 and y6. So from power 3 to power 6 you have to switch. That's why just do the square. Do square on both the sides. So when you will do square on both the sides, you have to use a plus b whole square and a minus b whole square formula. After using this formula, you will get this step. Now here t square, and here you have, students, x to the power 6 plus y to the power 6, and in the question just see x to the power 6 plus y to the power 6 is given to us t square plus 1 upon t square. So instead of these two, replace it by t square plus 1 upon t square and write the other terms as it is. And here we had used a square plus b square minus 2ab. So t and t will remove, so we will get only 2. Now this t square and this t square will cancel. 1 upon t square and 1 upon t square again it will cancel. So you are remain with this term and only minus 2. So here this y cube just keep here only, 2 and 2 will cancel again, and this is x cube is in multiply, so it will go in divide. Now differentiate this equation with respect to x, because whatever you have to prove in that you are having dy over dx, means you have to differentiate with respect to x. So differentiate it with respect to x. So derivative symbol will come both the sides, and this you 1 upon x cube just write down in the power notation in the numerator as x to the power minus 3. So here also just use x to the power n formula, that is n x n minus 1, and here also that will give you this step. So y cube, that is y, that's why 3y square, that is n y n minus 1. Then apply the chain rule. Here also this minus sign as it is, and then n x n minus 1, and then apply the chain rule. So this term as it is, and here minus into minus is plus, and here because of n minus 1 in the formula we have n minus 1, and here n is what, minus 3 and minus 1 because of formula, that will give you minus 4, and dx over dx, that is x differentiation is 1, that's why 1 came here. Now this 3 and this 3 both will cancel each other, and since its power is negative, so it will shift down. Now x to the power 4 is in division, so when it will come in this side it will multiply, and this is the required result which we have to prove. Hence this result is 2. So the question number 5th and 6th is completed. I hope it's clear to you. So in this exercise mainly the x and y are given in different parameters. So x and y differentiate separately in whatever parameter they are giving. You take care the formulas always in your mind and apply the chain rule until you reach innermost function. Thank you.